A hiker's trip consists of 3 segments. Path A is 9 kilometers long, heading 60 degrees north of east. Path B is 8 kilometers long in a direction due east. And path C is 4 kilometers long, heading 315 degrees counterclockwise from east. We want to graphically add the hiker's displacements in the order ABC. If you want to do a graphical addition, you must draw to scale, and therefore you must use a ruler and a protractor. Instead of graphically adding them, we're going to use the component method in order to add these vectors. So in the component method, the first step is to split every vector into the 2 components x and y. So let's take the first vector, which is, so let me draw the reference directions. So this is my east, west, north, south. So the given vector is 60 degrees north of east and is 9 kilometers long. So therefore, from east, you should be drawing 60 degrees in the north direction, and this is 9 kilometers long. So I can clearly split this vector into 2 components, one in the east direction and one in the north direction. So let's call this x1 and y1. We can solve for x1 and y1 using trig ratios. Which trig ratio would you use in order to solve for x1? Right, since x1 is the adjacent side of this angle, if we use cosine 60 equals adjacent over hypotenuse, so x1 over 9. So x1 becomes 9 cosine 60, which is 4.5 kilometers. Similarly, let's solve for y1. Sine 60, we want to use the sine ratio because sine is opposite over hypotenuse. You could also, because you know the hypotenuse and one of the sides, you could also use the Pythagorean theorem. So sine 60 is y1 over 9. So y1 becomes 9 sine 60, which is equal to 7.79 kilometers. Now let's split the second vector b into components. B is 8 kilometer long in a direction due east. So our b vector is just in the east direction. So that means there is no need to split it into components. So I know that the x component for b is 8 kilometer and the y component is simply 0. And let's talk about c. C is 4 kilometer long, heading 315 counterclockwise from east. So what does that mean? So let me redraw these directions. If this is east, starting from the east, if you go counterclockwise for 315 degrees, this is 90, 180, 270, and then 315 will be somewhere here. So let's draw this vector, and that's going to be 4 kilometers long. So if this whole thing is 315, and we know this is 270, then this must be about 45. So now let's split this into components along the y and along the x. So this will be our x3 and this will be our y3. So again, using sine cosine ratios, if you do the cosine, in this case cosine 45 turns out to be adjacent over hypotenuse, so y3 over 45. So then y3 becomes 45 cosine, y3 over 4. So y3 becomes 4 cosine 45, and that would be 2.83 kilometers. And if you know that in a 45-45-90 triangle, the two sides are going to be equal. We can just say that x3 is also going to be 2.83 kilometers. Now let's put all these together. Now that we have separated each vector into components, we want to take a chart so that we can get all the x components together and all the y components together. So x1 is 4.5 kilometers, x2 is 8 kilometers, and x3 is 2.83 kilometers. All pointing in the same direction, so therefore all are positive. So if you add these together, you get 15.33 kilometers. In the y direction, we have y1 to be 7.79 kilometers, y2 is 0, and y3 happens to be downward, so therefore we have to give this a negative sign, so negative 2.83 kilometers. So therefore, if you subtract these two, you will get 4.96 kilometers. So it means all these three vectors, when added together, essentially have an x component of 15.33 and a y component of 4.96. So we're going to redraw this information into our new triangle. So 15.33 in the x direction and 4.96 in the y direction. So our resultant is going to be drawn from tail 1 to tip 2. So this is our resultant of all the three vectors. So now that we have reduced these vectors into right angle vectors, we know how to find the magnitude of this resultant. So yes, we're going to do the Pythagorean theorem to solve for the hypotenuse. So C is 15.33 squared plus 4.96 squared. Why don't you calculate this and verify the answer with me? So this will be 16.1 kilometers. And remember, resultant, we need two things, magnitude as well as the direction. So this is the magnitude of the resultant vector. In order to find its direction, we're going to solve for that angle. We know that tangent theta is opposite over adjacent, so it is 4.96 kilometers over 15.33 kilometers. And so theta is the inverse tan of 4.96 over 15.33, and that would be about 18 degrees. It's going to be 18 degrees north of east. So this here represents the direction of the vector. So to recap, if you have three vectors in random directions, your first step is to divide each vector into the x and y components, making sure that you give the appropriate sign for the x and y components when you transfer them. So transfer them into your chart. So you list all the x components together and then the y components together. Find the total x and the total y, and then form a new right angle triangle. Solve for the hypotenuse by using the Pythagorean theorem and solve for the direction by using tangent theta.